Tak warm up lagi suara. Assalamualaikum warahmatullahi wabarakatuh. And good morning everyone. Okay, so first kali hari tu saya perasan kita ada suara apa namanya? Suara saya punya kamera kot saya rasa. Dia memang sebab saya main wire dia, saya suka lipat. So dia macam ada bunyi tau, kadang-kadang dia akan bunyi zzz macam tu. So sekarang nak tanya dulu, clear tak? Okay tak? Ada tak bunyi zzz tu? Kalau ada saya kena buka kamera tu on balik. Bila dengar balik macam bunyi apa dah tu. Lepas tu baru teringat bunyi kamera rupanya. Oh by the way, breakfast lah semua orang. Tak ada masalah, tak apalah. Tapi kalau ada masalah bagi tahu Sebab hari tu tak perasan bunyi je. Saya dengar lagi sekali baru saya macam so annoying bunyi yang kat belakang tu. Okay, tak apa. Oh lupa pula speaking kan. Allah. Okay, so now let's proceed. We are going to finish chapter 3 today. So this is sequences and series and it will be the last lecture for sequences and series. So that means next week we are going to start with a new chapter, chapter 4. Okay, next. Let us do a bit of recap first before we start with what we are going to learn today. So the learning outcome for today is that you should be able to determine the general term in a binomial expansion a plus b to the power of n where n is a positive integer. So last time we just learned how to expand. So today we are going to determine the general term. General term that means tr plus 1. So we want to know what is this value. And then some specific term as well. So sometimes you might want to find the coefficient of x cubed, the coefficient of y square, or the term x cubed, the term y square. So what is the difference between coefficient and term? If let's say I give you 3x square, right? And the coefficient of x square is simply 3. But the term in x square, it will be 3x square. So those are two different things. So coefficient as well as term. So do make sure you know what is the difference between them. So coefficient is just the number and then the term together with it. Okay, so that is the first formula that we learned where n is a positive integer. So n z with a plus. So that is the first formula that we learned. And then the second formula for the binomial expansion, determine the expansion of 1 plus x to the power of n for absolute value of x less than 1 where n is a rational number. So now the second formula for the binomial expansion is when n is a rational number. So of course we can also use them for a positive integer, but normally we are going to use them if let's say we have some fraction and then let's say we have some negative integer. So this is when we are going to use the second formula. So altogether for binomial expansion, in order to expand something, you have two formula. The first one is we got to use when n is a positive integer. So yang ni memang strict In order to use the formula for a plus b to the power of n must be a positive integer. If you want to use the formula for 1 plus x to the power of n, then n can be any rational number. So most likely we are going to use them for fraction as well as the negative integer or negative number lah, senang sikit. Negative integer saya kira awak strict pula. Negative number, any negative number. Okay, so why do we have this absolute value of x less than 1? So this is for validity. What does validity means is that if we substitute the value of x on the left hand side and right hand side, we are supposed to get the same value on both left and right hand side. So untuk make sure kita dapat nilai yang sama sebelah kiri dengan sebelah kanan, when we want to substitute the value of x, it should be within this validity range. Kalau nak pastikan nilai yang sama di sebelah kiri dan kanan, kita kena pastikan nilai itu berada dalam nilai untuk validity. Okay, next. Right, so now we are going to proceed with 3.2. Let us finish the positive integer and then I'm going to proceed with the rational numbers. Okay, so binomial expansion, let us do a bit of recap. What happened when n is a positive integer? So the formula that we are going to use is a plus b to the power of n, where n c0, a to the power of n, b to the power of 0, n c1, a n minus 1, b to the power of 1, plus NC2 an minus 2 b square plus dot dot dot, and then this is the general term tr plus 1. So NCR an minus r b to the power of r, and then when we start we should be able to finish at NCN a to the power of 0 b to the power of n. So do notice that when you start you are starting with NC0 and the last one or the final one is NCN. Okay, so that is the first formula. So again, I repeat, this is only true if n is a positive integer. Okay, so now the binomial coefficient NCR, or the thing that you have NC0, NC1, NC2 and so on, those are known as the binomial coefficient. So the way we open it is that NCR equal to n factorial over n minus r factorial, r factorial. And then the thing about this factorial is this one. N factorial is simply n times n minus 1, n minus 2 up until n. So we simply gonna reduce them by 1 until we reach 1. So for example, 4 factorial will be 4 multiplied with 3, multiply with 2, multiply with 1. So that's the last one. Don't go up until 0, otherwise everything will become 0. So if let's say you have n plus 2 factorial, then it will be n plus 2 minus 1 to that, so n plus 1, and then n minus 2, oops, n minus 1, okay, n minus 1. And if you are too lazy to write down whatever you have up until 1, just write down factorial. So they will write down everything including 1. So after a few terms, bila kita dah ambil tu, kita rasa macam dah malas sikit, kita boleh letak factorial je lah. So nanti dia akan continue daripada nombor yang paling last. Okay, then specific term. So this is the general term where we have tr plus 1. So the formula is ncr, an minus r, b to the power of r. So basically this is the formula that we want to focus today because we want to find some specific term. Okay, next. Find the coefficient of y to the power of 5 and x to the power of 6 in the expansion of x plus y to the power of 9. Okay, so of course you can actually expand them. You will have 10 terms and then you're going to simplify them and then compare each of them with y to the power of 5 and x to the power of 6. You can do that. But I do find that if we have more than 5, it will be quite tedious for us to write down all those bracket. Tedious tau, leceh lah kiranya. Kalau kuasa ni tinggi sangat, dia macam leceh sikit untuk kita tulis bracket. And then we need to be extra careful with the power as well. Do make sure not to miss anything. So I don't normally expand if they want to find a specific term. So I'm going to use the formula for TR plus 1. Okay, so I'm going to compare them first with a plus b to the power of n because the formula for tr plus 1 is for a plus b to the power of n. So if you compare them, you should be able to see that the x is a, the y is b, and then n is 9. So you can easily compare them. A is x, b is y, n is 9. So once we compare them, we should be able to see the formula for tr plus 1. This is to find the specific term or the general term. Now we can easily substitute the value for the n, the value for the a, and the value of the b. Oops, forgot another n over here. Okay, so substitute inside this formula, we are going to get tr plus 1 is 9cr, x to the power of 9 minus r, and then y to the power of r. Okay, so normally we don't really need to simplify them. But let's say if you have some number inside of these two, then that means you should separate the number as well as the unknown. So biasanya kalau kata kita ada nombor dekat dalam tu, contohnya x over 2 or 2x perhaps. If let's say we have 2x to the power of 9 minus r, then you should separate them into two. So the first one is 2 to the power of 9 minus r. Another one is x to the power of 9 minus r. For example, if let's say you have negative x to the power of 9 minus r, then separate them into two. The first one will be negative 1 to the power of 9 minus r. Another one is x to the power of 9 minus r. Okay, so let's say you see anything else other than this term. That means if you see any number together with the unknown, do make sure to separate them. And then we're gonna simplify them until we have the simplest. Okay, so now both of them are actually different unknowns, so there's nothing else to simplify actually. So we can just simply write down 9cr, x to the power of 9 minus r, and then y to the power of r. Okay, so I want to find y to the power of 5 as well as x to the power of 6. So let us compare with y to the power of 5. So if you compare with your specific term or your general term, you should be able to see this is y to the power of 5, this is y to the power of r. So you can compare them. Okay, so if you compare, you should be able to see y to the power of r equal to y to the power of 5, which will simply give us r equal to 5. Okay, so once we know the value of r, which is r equal to 5, you can easily substitute into the formula above there. So t of 5 plus 1 is 9c5, x to the power of 9 minus 5, y to the power of 5. And then do simplify them. Do check using your calculator what is 9c5. So T6 is equal to 126, x to the power of 4, y to the power of 5. Okay, so if you go back to the question didn't ask for the term. They asked for the coefficient of y to the power of 5. Okay, so y to the power of 5 is this one. So the coefficient of y to the power of 5 is simply the number in front of it, which is 126 x to the power of 4. So separate y to the power of 5 aside. So whatever without the y to the power of 5, that is actually the coefficient of it. So the coefficient of y to the power of 5 is 126 x to the power of 4. Okay, so now another one is x to the power of, I can't remember, x to the power of 6. Okay, so we're going to compare with x to the power of 6. So compare the term with x. So this is the term with x. So we are going to compare them with x to the power of 6. So x to the power of 9 minus r is x to the power of 6. So we got a similar base over there. We can easily compare the index. So r is actually equal to 3. So if you cannot really see how, so 9 minus r is equal to 6. Bring this one to the right hand side. So we got 9 minus 6 equal to r. So r must be equal to 3. Okay, so once you know the value of r, of course, go back to the specific term or general term formula above here. Substitute with the value of r with 3 now. So T3 plus 1 is 9C3. X to the power of 9 minus 3, y to the power of 3. So we simply follow the formula. Okay, and then of course, you're going to use your calculator, find out what is 9C3. So T4 is 84 x to the power of 6, y to the power of 3. And again, the question we're asking for the coefficient of x to the power of 6. So this is x to the power of 6. So other than x to the power of 6, we have 84 y cubed. So that means the coefficient of x to the power of 6 is 84 y cubed. So the coefficient of x to the power of 6 is 84 y cubed. So that is how Miss, kalau kalkulator hitam macam mana nak tekan untuk C tu? Oh, okay, sorry Hakim, baru tengok. Okay, so you should use the shift plus with divide. So kena tekan dua benda lah untuk keluarkan C. So contohnya dekat sini 9C5 kan. So kena tekan 9 dulu. 9, lepas tu tekan shift. Shift, lepas tekan shift, tekan bahagi. So sepatutnya dia akan keluar 9C lah. Yang ini shift dengan bahagi ni dia akan jadi C. And then 5 at the back. And then of course lah tekan equal. So nanti dia akan keluar nilai dia berapa. So kalau untuk yang ini kiranya 9 and then shift and then divide. 9 shift divide and then 3. So this is 9C3. So they will give you what is the value then. Kalau kalkulator yang lagi satu tu saya tak ingat lah. Saya rasa ada kot. Dia ada C siap-siap kot. Kalau tak ada nanti inform Saya ambil lagi satu kalkulator kat depan. Okay. So now done with this. Let us proceed with the second example. No more question for this one? Any question so far? Okay. So no. Let us go to the next one. Okay, so determine the terms independent of x in the following binomial expansion, x plus 1 over x to the power of 8. Okay, so we want the term independent of x, so that means we are looking for a specific term. So if we have a specific term, therefore we are going to use the general formula or this formula for the specific term. We are going to use that formula. So we are going to use TR plus 1. Okay, so compare this with a plus b to the power of n. So you should be able to see that x is a, 1 over x is b, and then n is 8. So a is x, b is 1 over x, n is equal to 8. Okay, so we want the specific term. So compare first. Find out what is a, b, and n. So ada 3 benda lah kena cari. A, B, N. And then what do you do next? Is that you are going to use the formula for TR plus 1. Okay, so TR plus 1, NCR, AN minus R, B to the power of R. So this is the formula for the specific term. What do we do next is that we are going to substitute the value of N with 8 over here, and then we are going to substitute the value of A with x over here, and then n again with 8, and then substitute the value of b with 1 over x. So substitute everything first. Okay, so they will become 8cr x to the power of 8 minus r, and then we have 1 over x to the power of r. Okay, so now we are going to collect like term. Kita akan kumpulkan term yang sama. Okay, so this one over here, 1 over x, I can actually simplify this, or I can actually bring the power up where they will become x to the power of negative 1. Okay, so I have 8cr x to the power of 8 minus r, and then 1 over x, change it to become x to the power of negative 1 to the power of r. And then go back to the rules of indices. So sebab ni saya minta buat mind map siap-siap, senang. Kalau rasa lupa je, tengok mind map, cepat je dah dapat dah formula apa. Okay, so this is a to the power of m over am n. So this is equal to a to the power of mn. So you should times your index. So they will become x to the power of 8 minus r minus with r, because this one is x to the power of negative r. So you have the same base over here, x together with x. So you're going to combine them together. It will become 8 minus r minus r. Okay, so simplify them a little bit. So TR plus 1 is equal to 8CR x to the power of 8 minus with 2r. So do make sure to simplify until the simplest one before we calculate what is the specific term. Soalan dia lah sebelum kita go to the terms independent of x. Do make sure the general term is already in the simplest form. Mesti dalam bentuk yang paling simple. Okay, so now I want it to be independent of x. What do I mean by that? So independent of x, that means x must be to the power of 0. Because if x is to the power of 0, I'm gonna get 1. So there will be no longer x. There will be no x anymore. So that is why we say if it is independent of x, then x must be to the power of 0, because x to the power of 0 is equal to 1 and we don't have any x anymore. Okay, so now let us compare then. So this is x to the power of 8 minus 2r. We are going to compare them with x to the power of 0. So by comparing, we should compare your index. So 8 minus 2r is equal to 0, which means that r must be equal to 4. Okay, so now once we know what is the value of r, go back to the general formula, substitute the value of r in. Okay, so we got t, 4 plus 1 is 8c4, x to the power of 8 minus 2 times with 4. And then again, of course, you should use your calculator for this. So t of 5 is simply equal to 70. So this one is x to the power of 0, so you should be able to simplify them to become 1. Okay, so that is how we get a term that is independent of x. As you can see, there is no x at the back. Tak ada x kuasa 1 ke x kuasa 2. So this is independent of x. So again, keep in mind, whenever we say independent of x, it simply means that x must be to the power of 0. Or you can say that it must be a constant. So kalau dia nak constant term pun sama jugalah. So independent of x or constant term, they mean similar thing where we have to compare with x to the power of 0. Okay, so done with this one. So the term independent of x, independent of coefficient of x. Ni tersalah ni, independent of x. Copy sangat kan. Jadi macam tu lah. Okay, next. Binomial expansion. So now we are referring to the second formula where n is a rational number. Okay, so what is the formula? Oh, miss out the one. The one should be here. Dia ke tepi sangat, tak nampak lah. Okay, so 1 plus ax to the power of n, that is 1 plus n multiply with ax plus n minus 1 over 2 factorial ax square plus n minus 1, n minus 2, 3 factorial ax cube plus dot dot dot. Okay, so we have a validity over here where absolute value of ax should be less than 1. So if you open using the second chapter, open the modulus. So ax will be in between -1 and 1. And then of course we are going to make x as the subject so that we exactly know what is the range for our validity. Okay, so binomial expansion, this formula, if you look at them very, very, very carefully, the first one over here, the digit is always 1. Definitely 1. What if the digit is not 1? So for example, if let's say you have 2 plus x to the power of -1, the number is not 1. So what should you do? Factorize out. So 2, 1 plus x over 2, and then everything to the power of -1. So it will become 2 to the power of -1, 1 plus x over 2 to the power of -1. So this one, this is the thing that we should expand using this formula. So kalau nak guna formula ni, wajib the first digit will need to be 1. So it should be 1 plus something or 1 minus something only. So you cannot have any number other than 1. If you have any number other than 1, you should factorize them first. Okay, so now the second one. So take the power, bring them down, so n, and then simply take this one, ax, and then n, you deduct 1 to the power, so n minus 1. As you can see, you have 1, 2, 2n, so divide with 2 factorial. And then ax also to the power of 2. And then we have n minus 2. So how many n? 1, 2, 3. So 3 factorial. And then ax cube. And then plus dot dot dot. Plus dot 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 means that you can actually do another one with ax to the power of 4, ax to the power of 5, and ax to the power of 6, and so on. It's keep on going infinitely. But of course, normally in our syllabus, we only stop up until x cube or perhaps x square. So it depends on the question. Kalau dia tak cakap ataupun dia tak mention, biasanya kita memang akan expand sampai x cube sahajalah. Okay, next. Right, so now expand 1 plus 3x to the power of 1 over 3 in ascending powers of x until and including the term x cube. So we are going to try to expand them until x cube. So I already write down my formula over here. 1 plus ax to the power of n, this formula. Okay, so you should compare first. This number is 1, this formula is 1, so we are good to directly use the formula. If the value for our question is not 1, so if this one is not 1, then you need to factorize the number out first, simplify a little bit until we have 1. Then we can use the formula. Okay, so now the first digit is already 1, so I can simply expand them straight away. Okay, so what is your ax? So compare ax. So this is 3x, positive 3x. This is positive ax. So ax will be equal to 3x. And then n will be equal to 1 over 3. Okay, so now we are going to substitute into the formula one by one. Okay, so 1 plus 3x to the power of 1 over 3. The first term, definitely 1. No choice. Definitely 1. You will not have anything else other than 1. Definitely. And then n multiply with ax. So we have 1 over 3 multiply with 3x. So that is n ax. And then n minus 1 over 2 factorial ax squared. Okay, so what is n? Okay, n is 1 over 3. And then 1 over 3 minus them with 1. So you are going to get negative 2 over 3. Divide with 2 factorial. And then we have ax squared. Okay, so this one is n minus 1, 2 factorial ax squared plus n minus 1, n minus 2, 3 factorial ax cube. And then don't forget you have to write down plus dot dot dot. Okay, so now we are going to try to simplify them. Okay, so make sure you have your calculator with you. Okay, so I do see 3 multiply with x. So I'm going to separate the number as well as the x. So this one, I'm going to separate them to become 3x square. So it will become 3 square. Square. 3x cube. So 3 cube x cube. Right. So once you separate them, it will be easier for us to use our calculator. Okay, so the first term for this one is already 1. So you just need to calculate this one over here. The second term. Yang 1 ni memang settle lah. Tak payah ubah apa-apa tau. Salin je balik 1. But 1 over 3, you should times them with 3. Yang x nanti kita salin je. So 1 over 3 times 3. Letak je bracket. So it will become 1. So 1 over 3 times 3. So this is equal to 1. So nanti x tu duduk kat belakang je. Boleh nampak ke? Tak nampak, saya pakai colour lain lah. Sekejap. Okay, so make sure over here 1 over 3 multiply with 3. And then x. So 1 over 3 multiply with 3 dapat 1. So kita akan dapat 1 darabkan dengan X. So the answer for this one will be X. And then this one over here, use your calculator. So you have 1 over 3, you times them with negative 2 over 3, you times them with 3 square. And then you divide them with 2 factorial. Lepas tu jawapan untuk yang ini baru kita darabkan dengan X square. Okay, so simply use your calculator. 1 over 3, negative 2 over 3, and then 3 square. Divide with 2. Dia jangan tertinggal bracket ya. Kalau tertinggal bracket biasanya nanti payah nak kira. Ni pun dalam bracket juga. Okay. So now the third one. 1 over 3, negative 2 over 3, negative 5 over 3, and then 3 cube. And then you divide with 3 factorial. So 3 factorial, jangan lupa kena tekan factorial. Factorial tu kena tekan shift. Factorial ni, shift. And then the symbol is X negative 1. So kalau tekan dua-dua ni, kita akan keluarlah factorial ni. Okay, so once you use your calculator for them, the answer will be 1 plus X minus X squared plus 5 over 3 X cubed plus dot dot dot. So this is the expansion. So we have answered the first part where they want you to expand. Okay, so let's say the question were asking for validity. What should you do? Okay, so if let's say the question were asking for validity, then the validity for this, so we have 1 plus AX, right? So this is our AX. So take your AX, put them inside the modulus, let it be less than 1. So 3x will be in between negative 1 as well as 1. So x will be in between negative 1 over 3 as well as 1 over 3. So yang ini kalau dia minta lah validity. Dia tak minta, tak payah buat, tak apa. Tapi sajalah first example kan, so saya tunjuk lah. Okay, so again, simply take whatever AX that you have, compare and then take your AX, put them inside the modulus. Make it less than 1. Kenapa less than 1? Syarat dia memang macam tu. Kalau kita nak bagi benda tu converge, memang kena less than 1. Okay, so open it. So it will be in between negative 1 and 1. So make sure you have X as the subject. Bring the constant to the right and the left hand side. Okay, and then you are good to go. Okay, done. Next. The second part, what do they want? Okay, so they say by substituting 1 over 1 to 5, find the value for cube root of 2 up to 5 decimal places. Okay, so this is our expansion earlier. What do we need to do is that we have to substitute x equal to 1 over 1 to 5. Okay, so when you are using substitution, you should substitute both on the left and right hand side. So that is why it is very crucial for us to write down this final line. So bila kita dah expand tu, tulis dalam satu baris yang ada kiri dengan kanan, so that it will be much more easier for us to see what is the number that we should substitute. Okay, so now we will substitute 1 over 1 to 5. Okay, so 1 plus 3x, so 3 times with 1 over 1 to 5 plus 1 over 1 to 5 minus 1 over 1 to 5 square plus 5 over 3, 1 over 1 to 5 cube. Okay, so now the left hand side, we're going to simplify them a little bit. So normally for the left hand side, we don't really use our calculator. Maksudnya kita tak apply power dekat sini lah. Kita hanya kira saja benda yang dalam bracket tu hasil dia berapa. But on the right hand side, this one you should use your calculator. Calculate this using your calculator. Okay, so calculate left hand side, right hand side. You should be able to see that on the side over 1 to 5 to the power of 1 over 3. Meanwhile, on the right hand side, I already used my calculator for them. And the answer for this is 1.007937. Okay, so now if you refer to the question were asking for 5 decimal places. Oh, dia ketuk lah pula dengan titik tu. Okay, so 5 decimal places, that means the working over here should be more than 5. The final answer dia nak 5. So our working should be 6 decimal places. Final answer nanti baru kita bagi 5. Masa working kita akan melebihi daripada tu. Okay, so 1 to 5 to the power of 3 is 1.007937. I should modify the left hand side a little bit so that somehow we should be able to come out with the cube root. So this is my aim. I want to get cube root of 2. So now from 1 to 8 over 1 to 5, let us find out if we have any number. Selalu square number kan, sekarang cube number. Okay, so now 1 to 8 over 1 to 5, 1 over 3 is 1.0079. So if I find out the cube number for them, then it will become 64 multiplied with 2 over 1 to 5. So I just choose the highest cube number that I know. So you boleh tengok lah, 1 to 8, you compare. Can you divide them with 2 square or 3 square? 2 cube, 3 cube, 4 cube, 5 cube, 6 cube, so on. So just find the highest one that you can find. So for me, I do find that I have 64 multiplied with 2. So this is the highest one, the highest cube number that I can find, which is 64. And 1 to 5, that is already a cube number. So I just leave them as 1 to 5. So cari cube number Okay, now I'm going to apply the power for them. So I have cube root of 64, cube root 2, cube root of 1 to 5. And then cube root of 64 is simply equal to 4. Cube root of 1 to 5 is simply equal to 5. So I have 4 apply with the cube root of 2 of 5 equal to 1.007937. And then I want to make sure I have cube root of 2 as my subject. Therefore, I should times them by 5 and then divide them by 4. So the right hand side will be times with 5 and then divide them by 4. Okay, so multiply them with 5, divide them by 4. So I will have cube root of 2 as the subject. And then you're going to calculate the right hand side carefully, giving your answer correct to 5 decimal places. So 2 is 1.25992. So this is my final answer. So now as you can see, this is 5 decimal places. There's more compared to our working just now. Just now our working, we always have 6, right? 6 dp. So this is 5 decimal places. Okay, so done with example 3. So we only have one left, which is example 4. Okay, so now let us proceed. Okay, so example 4, by using binomial expansion, expand 2 minus x 1 over 2 minus x square in ascending powers of x until the term x cube, sorry, x square pula. Okay, so now we have 1 over 2 minus x square. Formula is 1 plus ax to the power of n. So I don't have the formula for 1 over something. Or what should we do is that we should bring this one up first. Okay, so bring them up. So we have 2 minus x to the power of negative 2. But we still have a problem because if I want to use the formula, I must have 1 in front. But this number is 2. They are not 1. Therefore, I should factorize the 2 out first. Okay, factorizing the 2. So we have 2 multiply with 1 minus x over 2 to the power of negative 2. So make sure you use a big bracket for them. And then for each of these, we should apply the power. So it will become 2 to the power of negative 2, 1 minus x over 2 to the power of negative 2. And then this number in front, you can actually simplify them. 2 to the power of negative 2. So 2 negative 2 is simply 1 over 2 to the power of 2, which is 1 over 4. So we're going to simplify this a little bit. Okay, so we have 1 over 4, 1 minus x over 2 to the power of negative 2. So now I already have 1 over here, so that means I can use the formula for the binomial expansion. So before I with the next slide tu dia mungkin nampak macam tak berapa clear sangat. So for you to continue from here, bahagian bawah tu, make sure you use 1 over 4, make a big bracket so that you can see what happened after expand 1 minus x over 2 to the power of negative 2. So you expand this, you put them inside the big bracket. After we simplify everything inside the bracket and back with 1 over 4. So that is our aim. Okay? So we have 1 over 4, 1 minus x over 2 to the power of negative 2. We were to write down 1 over 4 and leave a big bracket because we want to expand 1 minus x over 2 to the power of negative 2. Okay, now let's question. Okay, so expand this one. So a is negative x over 2, n is simply equal to negative 2. Okay, so 1 over 4. So the first term, definitely 1 in the expansion. Okay, so 1 plus n multiply with ax. So we have negative 2 multiply with negative x over 2 plus n n minus 1 over 2 factorial ax square plus n over n minus 1 n minus 2 3 factorial of multiply with ax cube, and then of course plus dot dot dot. Okay, so now we're gonna simplify them one by one. Like I told you before, better for you to separate the numbers and the x. Okay, so for example over here, make sure to calculate negative 2 and then negative 1 over x. So you're gonna calculate this number first and then time with x later on. Okay, so this one negative 2, negative 3, negative 1 over 2 square over 2 factorial. And then you have x square at the back. For this one over here, make sure to calculate negative 2, negative 3, negative 4, and then negative 1 over 2 cube. And then you divide them with 3 factorial. And then of course you have x cube at the back. Okay, so I'll give you around 1 minute for you to try using your calculator, and then later on we're gonna check our answer. Nak minum air tak? Dahaga. Okay, so now let us proceed. Be extra careful with the sign Sign tu kena pastikan dapat betul Jangan ignore sign negatif kat depan ni. Pastikan masa guna calculator tu jangan ignore simbol negatif tu. Because you might have a positive or negative value. So be extra careful with the sign. Is it positive or negative? Okay, so now the final answer for them is 1 plus x plus 3 over 4x squared plus 1 over 2x cubed plus dot dot dot. So when you expand them, you will have something like this. Therefore, what do you need to do now is to times 1 over 4 which with each of the term. So you're going to times them one by one over here. Okay, so times with 1 over 4. Then your final answer is 1 over 4 plus 1 over 4x plus 3 over 16x squared plus 1 over 8x cubed plus dot dot dot. So that is our expansion. Okay, so now I think we're looking for D now. So A, state the range of x for the expansion to be valid. Okay, so in order to state the range of x for the expansion to be valid, we have to refer to our binomial expansion. What is the thing that we expand? So we expand 1 minus x over 2 to the power of negative 2, right? So you're going to take this ax over here and then put them inside the modulus, make them less than 1. So pastikan kita ambil betul-betul yang kita expand tu tau. Don't take the question. You have to refer to when you expand them. Where do you expand? Okay, so take x over 2, put them inside the modulus, make them less than 1. Negative inside the modulus, it will become positive. So kalau tak nak letak negatif ni pun tak apalah, tak kisah pun. Boleh letak positif je terus pun tak apa sebab dah dalam modulus. Okay, so now open the modulus. So x over 2 will be in between negative 1 and 1. So I'm going to times everything by 2. So x will be in between negative 2 and 2. So for this expansion to be valid, the value of x need to be in between negative 2 and 2. So that when I substitute, I will get the same value on the left and right hand side. So the value will converge to the same value. Okay, next. So this is the validity. The second part, we should find the value of 1.9 to the power of negative 2 correct to 3 decimal places. Okay, so if you refer to the question, you have 1 over 2 minus x to the power of 2, right? And then you bring them, so this is 2 minus x. Your question is 1 over 2 minus x square. So when you bring them up, you have 2 minus x to the power of negative 2. Then you do have something in this form, which means you do have negative 2 in your power. So you can directly compare the number inside of the bracket. So if you compare 1.9 to the power of negative 2 with 2 minus x to the power of negative 2, then you can easily see that x will be equal to 0.1. Okay, so once you get the value of x, if you refer to part A, we say that x will be in between negative 2 and 2, right? So do check, are they inside this interval or not? Okay, so we have negative 2 up until 2, this is 0. 0.1 is somewhere here, 0.1. So they are inside this region. So this value is valid. I can easily substitute the value of x. So this is almost correct answer lah. Boleh lah kita nak kata correct answer to choose. Correct value to choose. Dia kadang-kadang kita boleh tengok dia direct daripada soalan. Yang kita boleh tengok je and then kita tahu kita nak ganti nilai apa. If let's say the question is not that direct, then sometimes you might need to use some guessing. But the thing with guessing is that you need to make sure that the value of x that you are guessing is somewhere within the validity range. Jadi kalau direct mudah sikit lah tahu nilai x apa yang kita nak ganti. Kalau tak biasanya kena pakai try and error jugalah. Tapi nak try and error tu mesti dalam validity lah. Itulah maksud dia. Sebab tu dia bagi validity range. So that we know from where. Okay, so now I want to substitute with x equal to 0.1. Okay, so substitute x with 0.1. So substitute all the x with 0.1. I will have 1 over 2 minus 0.1 square equal to 1 over 4 plus 1 over 4, 0.1 plus 3 over 16, 0.1 square plus 1 over 8, 0.1 cube. So that means 1.9 to the power of negative 2 is equal to 0.277. Correct to 3 decimal places. Okay, so done. I think that's it for the binomial expansion. Done, finish. Okay, so I'll see you guys later. So sekejap lagi saya bagi uh, Google Meet punya link. So nanti chat lah dekat sana. Saya bagi link untuk Google Meet. Don't forget to key in your attendance. So I'll see you guys later on. Thank you very much. Bye-bye everyone. Ada soalan ditanya kat Google Meet Bye.